everyone, again welcome to Jnana Learning. So today we are starting a new lecture session on electromagnetics, and this is lecture 1, coordinate systems. So if you are watching my lecture for the first time, please do subscribe our channel Jnana Learning. So here we start. So for in-depth study in electromagnetics, we have to have a thorough knowledge about the coordinate systems. Why? Because the physical quantities within electromagnetics are mainly functions of space and time. So to describe the spatial variations of the quantities, we have to define all points uniquely in space in a suitable manner which requires an appropriate coordinate system. So here comes the importance of coordinate systems in electromagnetics. So we have three well-known coordinate systems. They are Cartesian or rectangular coordinate system, circular cylindrical coordinate system, and spherical coordinate system. So first we move on to the Cartesian coordinates system, or which is known as rectangular coordinate system. So here is a pictorial representation of the coordinate system, that is a Cartesian coordinate system. Actually it is an intersection of three planes, that is a constant x plane, a constant y plane, and constant z plane. So three coordinates are marked over here, that is x axis, then the y axis, and the z axis. Here you can see the three constant planes. Now this is the three unit vectors on the three axes, that is ax, ay, and az. Now these three planes are mutually perpendicular to each other. So this is the xy plane, this is the yz plane, and this is the xz plane. So this is the Cartesian coordinate system. Now a point P within a Cartesian coordinate system, which can be represented with 3 points, that is x, y, and z. Now the ranges of these variables within the coordinate system, that is x varies from -infinity to infinity, y it also ranges from -infinity to infinity, and z also ranges from -infinity to infinity. Now a particular vector A in Cartesian coordinates can be written as ax, ay, and az, or it can be represented as ax plus ay plus az, that is with the using the unit vectors. Here ax, ay, and az are the unit vectors along the xyz direction. So once again, this is a Cartesian coordinate system, which is an intersection of three mutually perpendicular planes, that is constant x plane, constant y plane, and constant z plane. So these are the three unit vectors along the three axes, that is ax, ay, and az. So any point can be represented within a Cartesian coordinate system using 3 points x, y, and z, and any vector can be represented in this Cartesian coordinate system as explained over here. So that's about the Cartesian coordinate system. And second one, it is a circular cylindrical coordinate system. So this particular system is convenient when we are dealing with the problems having a cylindrical symmetry. So here shown the pictorial representation of the simply the cylindrical coordinate system. So here actually the three parameters for representing this coordinate systems are a cylinder with radius rho, and a vertical plane, and a horizontal plane z, that is a vertical plane with an angle phi and an horizontal plane. That is, it is an intersection of a constant rho plane, that is rho is the radius of the cylinder, then constant phi plane, that is a plane perpendicular to xy plane, that is this is the plane that is perpendicular to xy plane with angle phi from x axis, that is noted over here. This is the angle phi So this particular plane. And the third one is a constant Z plane that is parallel to XY plane. So the three planes which is important in the cylindrical coordinate systems are a constant rho plane, then that is a cylindrical plane, then constant phi plane, that is plane perpendicular to the XY plane with angle phi, which is noted over here. So this is that plane. And the third one is constant Z plane, that is parallel to this XY plane, which is a parallel to the XY plane. Now see, the three unit vectors here are a rho, that is along this direction, a rho, that is along the direction of the radius of the cylinder. Now the second one is a phi, that is along the angle phi, and the third one is az, which is along the z axis. So these are the three unit vectors within the cylindrical coordinate system. Now a particular point P in cylindrical coordinate system is represented by these three variables, that is rho, phi and z. Now for a further definition of these variables, that is rho, which is the radius of cylinder passing through P or the radial distance from z axis. Phi, it is the azimuthal angle and is measured from the x axis in the xy plane, and z is same as in that of the Cartesian coordinate system. Now regarding the range of variables, it is somewhat different from that of the Cartesian coordinate system. That is, in Cartesian coordinate system we have all the three variables ranging from -infinity to infinity, but it is not the case in cylindrical coordinate system. Here the first variable, that is rho, ranges from 0 to infinity as it is a radius. Now phi, which is an angle, so it ranges from 0 to 2 pi, and z, it is same as that of the case of Cartesian coordinate system, and it ranges from -infinity to infinity. So that is a difference in the range of variables from Cartesian coordinate system and cylindrical coordinate system. Now a vector A in cylindrical coordinate system can be written as a rho a phi az, or a rho plus a phi plus az, that is using the unit vectors. Here a rho, a phi and az are the unit vectors along this direction, rho, phi and z, and these unit vectors are mutually perpendicular. So we have some relations, that is the dot products between, that is a rho, which is equal to a phi, which is equal to az, which is equal to 1, and the dot product between the two unit vectors, it will be 0, and the cross product we get a rho cross a phi, which is az, a phi cross az is a rho, and az cross a phi is a rho is a phi. So that's about the second coordinate system, that is the cylindrical coordinate system. Now we move on to the third coordinate system, which is spherical coordinate system. So when we have the problems having the spherical symmetry, here we have to consider the spherical coordinate system. So this is the representation of spherical coordinate system. So here we have to consider a sphere instead of a cylinder with radius r. Now a cone with angle theta and a vertical plane. So here it is. So here this particular coordinate system is an intersection of a spherical plane of radius r centered at origin. Here shown the radius r. Then a cone having the z-axis as its axis and vertex at origin with angle theta. So we have to consider a cone, a sphere, then a constant phi plane which is perpendicular to xy plane. So these are the three planes. Once again I will explain. That is a spherical plane of radius r centered at origin. Then a cone having the z-axis as its axis and vertex at origin with angle theta. Then a constant phi plane. This is the angle shown which is perpendicular to xy plane. So as this is a 2D geometry, you can visualize it as a three-dimensional sphere, a cone and a constant phi plane. So that's it. Now here also we have three unit vectors, that is AR, a theta along this direction and a phi along this direction. So here any point can be represented with the variables r, theta and phi. Now here the range of variables again changes, that is for radius r it will be from 0 to infinity, then theta, that angle will be from 0 to pi, and phi plane it is from 0 to 2 pi. Again in this case also a particular vector can be represented in spherical coordinate with ar, a theta and a phi as ar plus a theta plus a phi. Now the unit vectors are mutually orthogonal, and here we have ar dot ar which is equal to a theta dot a theta equal to a phi dot a phi is equal to 1. Now again the dot products and the cross product relations are shown over here. So that's about the second one, that is spherical coordinate system. So these are the three coordinate systems, that is a Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. Now another thing which is very important regarding the coordinate system is the transformation from one coordinate system to another coordinate system. That is, if we know a particular vector in one coordinate system, we should know how to transform it into another coordinate system. For that we have some transformations, that is based on the matrix calculations. That is, here this is a transformation. The first one shows a transformation from, that is a cylindrical coordinate system to Cartesian coordinate system. So we get the values in Cartesian coordinate system using this transformation, and the second transformation is from spherical coordinate system to Cartesian coordinate system. Now the third one, it is a transformation from Cartesian coordinate system to cylindrical coordinate system, and this is from spherical coordinate system to cylindrical coordinate system. Again this one, it is from Cartesian coordinate system to spherical coordinate system, and the last one is from cylindrical coordinate system to spherical coordinate system. So you can substitute the values accordingly for the variables in the three coordinate systems, that is from which coordinate system you have to transform. You can substitute that particular variables, and by using the matrix calculation you can find out the parameters in the required coordinate system. So that's about the coordinate system. We will continue the lecture on electromagnetics the next time. So do watch all the lectures in electromagnetics, and also share your comments and suggestions. Keep watching. Thank you.